Hello, everyone. I'm Susan Nash, AAPG. Really happy to be here, and I'm so excited we have such a fantastic program today. We have Philippe Hervé, Spark Cognition, Sashi Gunturu, Petrabytes, Brian McDowell, Sabata Energy. And as we get started, I'd like to have everyone take a moment to look at your screen and find where the chat box is, because I'd like you to be sure to ask questions of everyone. And if we don't have time to get to the questions at the end, then we'll have everyone will have a chance to email. And you will get an email with a recording of this presentation. And you will also get links to a collaboration platform called Srathis. And after we finish this activity, we're going to put together a place for you to go and also continue to work on actually getting data sets and thinking about doing a challenge or an actual problem. So I'll be working with our presenters to see what we can do with that. Also, I'd like to announce that you will be getting an email that will have the links to an extended package. So if you need an additional professional development credit or CEUs, or would like to have access to more articles, it's only $35 and you'll have a chance to sign up for that. I used to put that in the same invitation, but then it caused all kinds of confusion. So I decided it's better to create that link afterwards and have everybody sign up separately for that. So that's how that's going to work. So at any rate, the way that this will work is we'll have one presentation, and then we'll save our questions for the end. Unless the person ends up at about 10 minutes, then we might have time for one question, but I'd really rather have everybody put their questions in the chat box. And then as you will see, everyone has a little bit different focus. So we'll have each person has a little bit different focus. We'll have Philippe with an overview, and then Brian McDowell will go second. And after that, we'll have Sashi Gunturu. And Brian will be talking a little bit more about the data itself. So at any rate, with that, we'll just get started. And I'd like to invite Philippe to share his screen. And here we go.
Thank you very much, Susan. Let me share my screen. We're coming. Okay, share. Hopefully, everybody now sees my screen. And thank you, Susan, for inviting me to speak today to this wonderful crowd. I can see that we already have a large attendance, and it keeps on coming in. So we'll try to respond to the expectation with the rest of the speakers.
Yes, and as we get started, I'd like to make a special request from the audience that if we could minimize lots of flashing or things like that, let's do so, because we don't want. So anyway, lots of flashing lights or pointers.
Okay. Hopefully I won't get too many of those. So I'm Philippe Hervé. I'm French. I want to apologize for the accent, and hopefully within a few minutes everybody will understand me. So just take it, listen. I'm the Senior Vice President for Energy and Sustainability at Spark Cognition. So what I want to address a little bit in this presentation is, yes, data is important, but why is it important? And so first, just one quick slide on Spark Cognition. So we are an AI company, artificial intelligence company, and we were created, and we have been predicting future outcomes, analyzing processes, preventing cyber attacks by analyzing and learning from all types of data. And all types of data is really what I want to stress on in this intro slide, because when I look at what geologists have to work on, you already have all types of data. So I'm going to show you a few examples and provide a few use cases which are going to demonstrate how we can work and what's the value of working with all types of data. But if you have data and if you need to organize your data in today's world, it's because you are going to want to use this data, and if the problem is a little bit complex, you are going to want to use artificial intelligence. And artificial intelligence is absolutely the future. But at the same time, let's look at what's good and what's bad about artificial intelligence. And so what is good is that with AI, we can solve any problem when data is available. Unfortunately, the problem with AI is that we can solve any problem when data is available. So, why is it a problem? It's a problem because we could use a very big hammer to try to put in the ground a very small nail. So let's make sure that we're going to be using the right tool for the right problem. And in order to know what tool to be using, you need to identify what is a business problem. So once you identify the business problem, then you can decide what technology is best adapted to solve that problem. And if you look at it, what is AI? AI is mathematics. So once you want to use mathematics, let's go back to the way we have been doing it previously. Is if you need to do something simple, 2 + 2, hey, I'll do it by head. I know how to make 2 + 2. If it gets a bit more complicated, I may pull up a piece of paper or small calculator, or maybe if it really starts to get past what I can do with those, I'm going to pull out my computer and use Excel, MATLAB, or whatever other piece of software I may need to solve that particular problem. With AI, it's the same thing. You need to be able to triage those problems, what it is you're going to need to do by hand, and what is going to require a full-blown AI solution. So in order to know how you're going to use your data, it's very important to define the business problem so that you adjust the solution to the problem. One of the questions I hear very often from clients or people investigating is my company ready for AI? And in fact, is my data ready for AI? And do I even have data? So I'm going to tell you, you do have data. But the next question that comes up from the people who says I have data, yeah, but my data is not ready for AI. I've not put it yet in a state of where it's perfect for AI. And perfect data doesn't exist. I'm very, very sure of this. Perfect data doesn't exist. We'll never get it perfect. When we had in drilling only about 10 parameters to work with, hook load, bit, weight on bit, RPM, and a few more flow in, flow out, and mud weight. We could not get those adjusted today. Out of a more modern production platform, we probably have 15 to 30,000 data points coming out. So trying to get all of them perfect is impossible. And once you try to store them, what do you store? What do you keep? What do you organize? What is the data you really need? You cannot know. You can go and try to store and make everything perfect, but if you have not decided what is a business problem, then you're going to spend a lot of money to get data ready for what you want. So what is perfect data to me? Perfect data is data that is going to solve the problem that you want to fix. So we go back to that business problem. What do you need to fix? What is the challenge? Then you are going to adjust the data for it. And the best way to adjust your data is to start using it, and start using it today. Use the data you have to solve particular problem. And as you discover what's wrong with your data, then you're going to be able to improve your data based on the business requirements. Maybe you realize that, hey, I should have organized it a little bit differently, or maybe I need a bit more data, more accurate data, different type of sensor. But unless you start to use your data, you don't know what is the value of your data. So make sure that you understand what is the business problem and that you start using the data and organizing it based on how you can use it. Once you start to use your data to define some outcome, you realize what's good, what's bad, and what needs improvement. But if you wait for your data to be perfect, you will never get started because, as I said before, perfect data doesn't exist in my mind. And so if you keep on waiting, you are going to have to decide if you want to be Blockbuster or if you prefer to be Netflix. If Netflix is more attractive, please do get started today. There is no better day to get started if you are not already on the bandwagon of artificial intelligence. And yes, you need data, and I wish we had perfect data, and organizing your data is extremely important, but using your data for the right business problem is what's going to drive your strategy. Now, as we speak about data, we cannot avoid speaking about cybersecurity. So I'm going to spend a very short time on this. But with cybersecurity, today we have one new malware every 39 seconds. That's about 1 million malware per day, new malware. And even with what's happening in Ukraine and Russia, we get even more malware coming to the rest of the world. So it used to be that we would capture all of this malware around the world on iPods, and then we would extract their signature and send the signature to every single endpoint around the world. That paradigm is broken. It worked when we had one malware per quarter, but with 1 million malware per day, this doesn't work. We cannot work this way. So we need to change, and that's where AI came to the rescue. With AI now, we can install an endpoint protector onto your Linux, onto your iOS, Apple, Windows device, and that AI endpoint protection is going to protect you against all the traditional malware, as well as all those day zero malware. So something brand new, never seen before, we're going to block it right there without any daily update. So that's fantastic for IT and OT. And if your company are not yet looking at cybersecurity, please do it. If you're not yet looking at AI for cybersecurity, please do it, because the hackers are using AI to create new malware. So we need to be always in front of them, or you're going to be in trouble. So much about AI and cybersecurity. But why do I speak about artificial intelligence, and really what is the status of AI today? What are the type of projects that we have worked on at scale? I'm not speaking about a small proof of concept. I'm speaking about large project. Anybody can do, with a good data scientist, a proof of concept and demonstrate that AI is the right solution to a problem. Scaling it up from a proof of concept to a very large project is where the challenge is, and that's something we have done in many, many places today. So today, using AI, we actually deployed on over 25,000 cameras in 16 countries, using visual AI for safety, for warehouse management, for many other use cases. And I'll come back to this in just a second. But we also move today about 3 billion barrels of oil globally by managing the fleets of some of the largest operators in the world, so optimizing the scheduling. Today, we manage also about 30,000 drones in over 100 plus countries. The largest implementation of that technology to do the air traffic control on the asset management of drones. That is known. That's SkyGrid is a joint venture between Boeing and Spark Cognition. So very large implementation here. We manage, I need to update that slide, we manage today about 9.5 gigawatt of renewable energy. 9.5 gigawatt is a very significant number in that world if you don't know about renewable energy, but this is a big number. We are also in the defense world. We are recently one of the main players in what was the world's largest maritime exercise between friendly nations. where we provided all of the sensor fusion technology. Sensor fusion is where you use radar, video images, LIDAR, all type of various technology to reproduce a 3D environment, to understand the 3D environment automatically. The technology is used also in the Defense Department to do the maintenance on the F-16 fleet. And obviously, more importantly to us, we have deployed the largest best-in-class production optimization, maintenance optimization technology on some of the world's most productive already. So many very large deployments looking at many different databases, type of data, structured, unstructured, time-based, all type of data. We had to look at those various cases to bring it together to deploy those very large-scale solutions. Let's look at that last project I just spoke about. This project was actually presented with BP in 2020 at the ADIPEC Award in Abu Dhabi, and was a finalist in the Digital Transformation Project of the Year category. And here we are really deployed now with BP on all of their offshore production platform in the Gulf of Mexico and in the North Sea, but also expanding with other clients around the world. We started with predictive maintenance. Is that asset going to fail? Is that generator, pump, compressor going to fail? But very quickly realized that what BP wanted to look at was, is my production going to be stopped? What are the production impacting events? And very quickly you realize that production impacting events are only in a few cases related to some asset failing, about a quarter of the time. Most of the time, a production impacting event is related to a process or a people failure. So being able to identify, predict, in order to mitigate them before they occur has been really what has helped us to optimize the production for BP and others on their very large offshore platforms. I spoke about maritime logistics. This is a use case where we had to integrate from about 15 different data sources, both internal to Aramco and external to Aramco. We manage the entire fleet today. The project was in 2021, the project of the year, received the Excellence Award at Aramco, and we delivered an annual saving on the logistical cost of $81 million. What's important here is, being able to scale up those projects, looking at many different data sources. I spoke a little bit about Vision AI, so let's see some rapid examples. This is a case where we look at...
Philippe, you have about 3 minutes.
Yep, sounds good. Here we're looking at that's not 15 minutes, Suzanne, but that's all right, I'll do it. Here we're looking at people coming in and out of space, and that's very important for looking at refineries or spaces where you want to know how many people were in and out of a complex, to know what in case of an accident, how many people are on location, and is everybody at the muster point. This is another place where we look at how many people are queuing up in order to organize the queuing, the logistics around the campus. Looking at the gas station, we are implemented already on quite a lot of them. Looking at, is a fire extinguisher there? Do we have delays or what's happening, and how do we optimize the traffic of the cars? Or we can also be looking into plants, who is coming in, who is coming out, capturing information on those particular trucks. What are they going to be doing in the plants? Do we operate in a safety environment? But let's look at how to successfully implement AI, and for this you need to look at why do projects fail? Because to me, a successful implementation of a data challenge of digital transformation is really a change management project. So you have to ask, why do projects fail? And they typically fail because you try to change too many things at the same time. You try to change the process, the people, the technology. And we all know that, if you want to change something, the biggest barrier to change are your people. So you need to convince the people with change management that this is an interesting project that is going to be valuable to them. And that's why when you start with AI project, it's important to start with projects that are as much as possible looking at technology and try to change the people on the process around that as little as possible. It's impossible to not change, at least to some extent. But if you can find project where you can change the technology more than the process of the people, such as predictive maintenance, maintenance still has to be done. But now you can predict when the maintenance needs to be done. This is how you're going to be able to get AI to work in your company, because for the next project where people will have to change, they will be supporting you because I've seen the value of AI. So what is AI really? AI is another voice in the room here of data, with probably the first version I saw on the TV of artificial intelligence. And data knows everything, and he makes recommendation. We never saw data taking a decision. He provides information to Captain Picard, Commander Picard, who makes the decision. So what is AI? It's really an augmentation of human intelligence. We are not at a place here yet where we're going to replace humans with AI. We are definitely augmenting the value of the humans. And with this, I would like to thank you for your time and give it back to you, Susan. Thank you so much.
Well, thank you. That was wonderful. Really enjoyed that. And you did a great job. Super interesting to see the use cases. So I'd like to invite Brian McDowell to share his screen and go next.
All right, can y'all hear me?
Yes.
All right, sorry, I'm still in the back end of the cold here. All right, so I'm going to go through mine relatively quickly because I'd rather do the questions towards the end. So what I'm going to do, kind of my part of this, is going to be on data challenges from a startup company's perspective. We're a real small shop. Our entire company is a handful of people. And just kind of going off the topics that Susan outlined, a lot of the stuff that's out there, kind of what Spark Cognition and Sashi's company are doing, is a lot kind of bigger scale for a lot bigger operators, stuff like that. For those of us where we only have a handful of people, all those options really just aren't economical or really time from a time perspective, just really aren't doable as well. So I'm kind of coming from that perspective. So going through what the topics were today, I'm only going to go through 4 of these. I'm going to have a couple slides on each of those. And like I said, it's going to be pretty high level. I'd rather answer the questions towards the end. So the first one that I want to talk about here is working with diverse data types. Now, we actually purchased one of the oil and gas libraries out here in Midland last, December of 2020. And then we also, at least our company, we also sell well logs, scrape well logs and stuff like this online. We'll talk about a little bit. So we spend a lot of time between trying to figure out how to classify and merge 2 different, very distinct types of data, which is the physical data in the digital data, right? You see most organizations will kind of specialize in one versus the other. And that's because they both have very different needs, whether it's storage, do you need physical space versus hardware space, server space? And then also, how do you classify all this stuff up? So from the physical perspective, which is what really our primary specialty is, I don't think a lot of people realize the variety of data mediums. By mediums, I mean the actual material that data is printed out on, and then also the formats. For us, we spend a lot of time working with paper data, mostly because that's the most common of what you see for historical legacy oil and gas data. So, we always have a lot of people who's like, well, does this stuff really matter? Well, if you're drilling a bunch of horizontal wells out in a basin that's never been drilled before, or maybe you have an enormous amount of well control and all of those well logs are available publicly, then the paper data probably doesn't matter as much. The reason we focus on this a lot more, because I think, in my personal opinion, as we see more and more of oil and gas start pivoting towards geothermal, towards carbon sequestration, hydrogen storage, helium production, stuff like this, the historical data is more relevant in a lot of ways, if nothing else, from an environmental perspective. And a lot of that only exists on paper, believe it or not. At the end of the day, I will tell you, IHS, Drilling Info, and TGS do not have everything in the world, even though they tout that they do. There's an enormous amount of data that are stuck out in libraries and private collections. So, but even working with just paper data alone, you have a huge variety of formats, right? Even just looking at well logs, you have the narrow format, you have the sample logs, which are very narrow and folded up, in like 2 to 5 foot increments. Completion cards are these on index cards versus on regular pieces of paper, and then even reports and stuff too. Then you really start getting to the hard stuff as microfiche and vellum. Vellum you don't see as commonly, so it's kind of the plastic material you see rolled up for all the other younger folks like me. And then microfiche, which is a whole resource out there that is not easy to scale or capture, that we've been trying to figure out ourselves. But I think we're all pretty familiar on the digital data side. The one thing I will kind of want to hammer on here, though, is not all digital data is on a server or on your network drive. We deal a lot with well files. So we literally go pick up a trailer full of bankers boxes that have been in a storage house or storage unit for God knows how many years, or maybe a decade or more. And how much of this thing is still LAS files. They might be the old style of LAS or TIFF files or core images or stuff like this that are still out there on floppy drives, CDs and DVDs, or external hard drives, stuff like that. I mean, we actually deal with floppies a lot. And another thing too is, especially when we're working with historical like mudlog data, a lot of these files are available. You can find digitally. However, the companies that actually created those proprietary file formats are gone now. And a lot of this stuff is lost forever. So even though you might have, say, a copy of a mudlog on a floppy disk or a CD, that doesn't necessarily mean you can actually access it. And this is what goes back to the physical data side, where you really need to be doing both if you want to do your really due diligence, I think, in a lot of these historical areas. Now, the way that we index this, the hardest part with physical data is actually indexing it. We create this, and I've showed these slides quite a bit, but we create a unique identifier, and then we actually capture an image. So for a well log, rather than actually scanning the entire well log, what we do is we create this little QR code. It has a 4-part code here, which I'll explain. We place it on here, take a photograph with an iPhone, and then we actually run a photo processing automated through a company called Geolumina. It's based out of Bryan, Texas now. They actually clip that image, enhance it, and kick it back out. So why do we do that? Well, number one, rather than scanning a well log, which can take anywhere from 5 to 10 minutes, depending on how good a shape it's in, we can actually take an image of the log header, which is infinitely faster. At the end of the day, you don't need to scan every single log. You just need to know what you have first, and then you can go scan it. If you look at it from that perspective, we index data about 5 times faster than what you can do by scanning everything, right? So think of this, and it's very cliche, but it's still true, is minimal viable product, right? If you've got 5,000 well logs, you don't need to scan every well log. You just need to know what you have so you can choose what to scan. And by doing that, we can go through about 1,000 logs a day per person, rather than going through, I believe on a good day when we scan, we might do maybe 200, maybe, right? So it's a big change. And then just how we do this, it's not really that important, but when you're looking at physical data, you need to think of a couple different things, especially when you're indexing it right. Stay away from APIs. Although API numbers are supposed to be identifiers, I would argue that more often than not, they just confuse the situation, especially in historical data. But the big things that we focus on is who's the data source, where's it coming from, what collection within that, right? So is it these mud logs, or is it, say, small scale logs? And then last but not least, what's the format, right? Because the format, even if I lose part of this other code, I can at least look at that and I recognize, like, okay, it's a small scale log. It should be a small piece of paper like this. Then I know what my data volumes are. Now, the way that we do this, like I said, we'll take these logs, put a QR code on it, take the image. We then run it through Geolumina's process where they crop the image automatically with some Python code and finally kick it out as this enhanced image, which essentially turns the yellow paper to white and makes the black and white lines pop. What's really cool is we also do this for digital well logs too. So we actually just take a raw TIFF file, run it through some Python code in-house, and actually kick out a QR code. Why do we do this? Well, at the end of the day, you can always preview that data first, rather than having to download an entire file to look at it. Okay. The other thing is, rather than me having to go through and pull top depth and bottom depth, manually off 1 million well logs, I can just hand you a million or access to 1 million JPEGs. So you go look this up yourself. So I'm not trying to like really sell y'all on our products. What I'm trying to really convey is think about what the bare minimum that you need, right? Especially when you're working with these bigger projects. This is where we see people get hung up. Now, the second thing I want to talk about is data cleaning and data integrity. I think we've all dealt with this a lot in varying degrees, but the big thing I want to hammer on is what are you trying to achieve? Are you trying to do actual data management? So something like OSDU or PPDM, right, where they spend an enormous amount of effort and resources trying to find better ways to structure tables. Well, for us, I think the big thing as geoscientists is data discovery, right? If I find a core report or some of this other stuff, well logs and stuff like that, if it's 1 million well logs, then yeah, I'm going to need some help managing that data. But if it's 100, I just need to know where those 100 well logs are located first, and then I can figure out how to put it together myself, right? Those are very different problems, whether it's the scale, the effort, the cost, and all that other stuff. So again, the level of data cleaning and data integrity you need to go into really needs to be focused on what your project is, I think. And again, I'm just going to hammer this one more time. I actually really like these cartoons. Are you looking for a short-term fix or long-term solution, right? We've all seen this diagram, right? You can get something good, cheap, fast, right? It's kind of the three categories. You can do two, but you can't get the third, right? So just think about this in the long run. Do you need something today or do you need something for 5 years, right? Doing something for a 5 million company in Midland, Texas is very different than rolling out something for ExxonMobil, right? And again, this is a meme that I actually took from Matt Harriman on LinkedIn, where he said this whole thing is like, I join tables by well name. As a data scientist, most of us, we see that immediately and like, oh my gosh, that's, we see this all the time. However, if you just need a quick fix, sometimes that's good enough, right? Rather than poo-pooing on whether you're doing it with Python and you hate Excel and blah, blah, blah. At the end of the day, again, this is AAPG, right? We are geologists, right? We are trying to get oil out of the ground, not make the prettiest databases, right? So keep it practical and, stay in the lane that you need to in order to get your daily job done. Now, as far as sharing and working with data securely, my recommendations, this is a small shop. I get no money from these guys, although I wish I did. It'd make it my overhead a little bit easier. Over the last 5 years, it's easier than ever to leverage manpower, either through programming or cloud computing. I know for us, we do everything almost purely on the cloud. There's just not really much reason to buy hardware, to be honest, unless you're really trying to or for very specific cases, in my opinion. Our preferences, the big ones that we use day to day, we use a software called Ignite, which is actually, think of it a network drive, but you can do it as a cloud service. So for those of y'all that are like starting up your own companies for the first time, this is a really great way to essentially have that network drive experience between multiple people that are on totally different laptops. Say one of us is in Midland, another one's in Houston, another one's in Austin. Makes it really, really easy to move stuff back and forth internally for a pretty low cost. Dropbox, we're all familiar with that. This is great for when you're delivering stuff to outside companies. Again, as a small company, something that's reasonable to deliver data to bigger shops. A lot of bigger companies have their security stuff is just a little over the top. Dropbox has been around for a while. It's a really easy way to deliver stuff. And then last but not least, when we talk about either storage or computing power, we bounce between Amazon Web Services and Microsoft Azure. You pay by the hour or by the gigabyte, essentially what you're storing. And then that ramps up and down depending on what your hardware needs are. And then the last couple things too, Python, as always, Python is an enormously helpful tool. Even with just a little bit of practice, you can get a lot done. And then also too, for database wise, we do almost everything on MySQL or PostgreSQL. These are open source SQL platforms. Now, is it going to be as robust as Microsoft SQL or Oracle? No. But again, when you're first starting out, those things can absolutely obliterate your budget. Getting a relational database on AWS for Microsoft SQL versus MySQL can be 2, 3, 4 times the cost, depending on what you're doing. And then the last thing I want to talk about here is the different data sources. This is really our bread and butter here, is that From what my perspective, what we try to do as a company is we're trying to find all the data that's available out there, not just get it all into a single table, because at the end of the day, most of us, we need to be spending our time actually going through the data, interpreting the data, and finding prospects and drilling wells, rather than trying to figure out how to structure these tables properly. You need a little bit of both, but there's obviously give and take. So right now you see most of our data, I would argue, in the oil and gas industry, split between either regulatory agencies, so think of the Railroad Commission, operators, energy libraries. There's a lot out there we forget about. Private collection, some guy's got a bunch in his garage, universities and service companies. And then what we're doing is we actually try to bring this into one location. Now, what's the nature of the problem? We talk about, let me step back again. So why are we integrating this from different sources? Okay. Again, just like before, think about, is this a short-term fix or a long-term fix, right? Is this something that's static versus dynamic? Meaning, are you going to pull it once? Or are you going to pull it once a week? Or are you going to pull it once a year, right? Those solutions that you put in there are very, very different of how you build those. And it also affects the cost greatly, okay? And the one thing I want to go through here, this is actually how our directory has grown over the last 6 months. And the one thing, when you talk about integrating multiple data sets, really go back to what they call the 5 V's in data science. Again, this is it's probably an overused term, but I cannot tell you how great this is. Is the velocity, how often are you get it, volume, how much is there, the value, how much does this cost, like how good does it really need to be? And then finally, variety, which is enormous geologically, and then veracity, how true is it? So with that, I think that's my time. So, and I'll yield the floor back to Susan. So appreciate y'all's time, and I'll take any questions at the end.
Thank you. That was great. Really appreciate it. So I want to just thank our speakers, and I really appreciate these different perspectives as well. So it's really, really nice. So I'd like to invite Sashi Gunturu to share his screen and proceed.
Thank you, Susan. Can you hear me okay?
Yes.
Yeah. So my goal, so I'm Sashi Gunturu with Petrabytes. So we are a data analytics company based out of Houston. So my goal is to take you from a 10,000 foot level to how do you get started? Okay, so and all about how do we make a cost-effective solution for mature fields, green fields, and also for energy transition. So if you look at all the upstream complexities, you have data like subsurface data, you have real-time data, you have some energistic standards and all these different data from different standards. That's some of the things that Brian was actually handling. And then also you have OSDU data formats that are coming up. So there is a lot of data. Same thing with production. You have pipeline data sets. Like if you see, there is facility data, there are reports, there are schedules, there is data from SCADA. And also, the pipeline data systems they're trying to build standards for that. So in all of these, it's an ongoing standard. I mean, it takes a lot of time. So you have these data challenges. Then you are looking at the renewable energy, like where you have structured and unstructured data. We have data from storage tanks, wind turbines, and also geothermal and time series data sets. And we have been talking to several operators. So apart from all the data challenges, they want to have governance, like who has access to what data. And Philip was talking about the data security, especially the cloud data security, right? So, and then you have vendors, like if you take companies like Exxon, they have hundreds of vendors, data in different countries. And then you have the big challenge is how do you securely share data without data duplication? So you have data challenges and you have the logistics challenges of moving the data. So in all of these, we want to ultimately extract value from data, right? So I like this phrase, like what Mark Zuckerberg says, like, because most of the time we don't know what problems are we solving. So you have a vague idea. So you want to actually start working on it in order to make better sense of what problem are you trying to solve. So in all of this, you need to engage the business early. You need to build an analytics ready platform, not just a data warehouse. So you don't dump data because you need the way to archive, you need to way to manage that entire data lifecycle. And you want to automate all the data ingestion and aggregation. You want to identify what is an ML problem versus an analytical problem, because most of the time everybody brands everything as an ML problem, which is not true. So you need to identify what problem are you really solving. And also build dashboards where you engage the business users. And you want to implement the DevOps and MLOps, because ultimately to secure more funding, you have to continuously keep delivering. So you don't have 5-year projects, you have sprints where people want deliverables, right? So you want to use this DevOps and MLOps methodology. And then as you're implementing, you want to start standardizing your data exchange. That's where OSDU is trying to engage all the operators and also the software vendors. In all of this, you want to go with a pay-as-you-go model. So you want to make it an operating expense, not a CapEx. So this is an example from a Canadian operator, how they actually have an approach to analytics. So they have an exploratory data analysis, they build a proof of concept, they build a minimum viable product, and also they have a continuous validation from the SMEs. So it is like an iterative, even the analytics is a continuously iterative process. So you want to engage in this cost-effective agile process in order to deliver value. So in order to have all of these, obviously we talk about cloud and distributed computing. So I just want to allude to how the transition has taken place from a client server to a completely cloud-based managed service right now. And then Spark has become the core of Scale because they implement the distributed computing, and it has support for a variety of languages. So in all of these, there is a new paradigm called the lake house, which has a clear separation of compute, storage, and analytics, right? So we are implementing the lake house for energy transition. I just wanted to briefly touch upon what can be done with the lake house. So typically you have a cloud data warehouse where you have more of a structured data, and then the data lake is more like a semi-structured data, but the data lake house is more like an analytics ready platform where you have data from images, all kinds of data, even the streaming and non-streaming data, structured and unstructured data, all in one place. So this gives you an architecture to make to really prepare yourself for an analytics ready platform. Again, it has a structured transaction layer where you have multi-user, multi-access, and all the different kinds for different kinds of data formats. And it also has a high performance query engine. And all of these are actually open source projects. If you see Spark, Delta Lake, MLflow, all these are open source projects that is driven by hundreds of people. And then they have companies like Databricks and Snowflake trying to commercialize on that. So you see faster innovation by implementing the lakehouse. And ultimately, everybody talks about data quality, right? So using the medallion architecture, you take data from raw, both streaming and raw data, and ultimately make it analytics-driven platform. So in all of these, you want a secure data storage, which has the entire data management lifecycle. And then you want to talk about, look at all the automation. In this case, we are looking at all the subsurface data that is moving with different data pipelines. And then you're processing all in the cloud, and then making it analytics ready. So this is the data lifecycle where we go through for structured and unstructured. We cleanse through all of that. Pretty much what Brian was talking about, applying business rules and cleansing. And in this case, we are ultimately populating into the Delta Lake. So ultimately, we feel the Delta Lake with the data lifecycle would be the future storage of data for, especially for the energy data, where you can take from upstream all the way to all the renewable energy. So there has been a lot of talk about OSDU in the last 4 years, where big companies wanted to standardize data exchange, pretty much how HL7 was doing for the healthcare industry, where they wanted to standardize all the electronic health records. The same thing is happening in the energy industry, where they want to standardize data. But the challenge is it's an evolving standard. And then this is where the lakehouse actually complements the OSDU. So in this case, you have data from on-prem to the cloud, and also all the whatever is the missing subsurface data can be actually populated to the lakehouse. So in this case, you have having the OSDU as the system of data exchange between applications. So these are our applications, but it could be any set of cloud-based applications. So this is how you can interact the OSDU mechanism with the Delta Lake. So it's actually complementary if you really look at it. And then the advantage with the lakehouse architecture is it gives you the change data control, right? Let us say you have 1 million records and only 50 of them have changed. Typically, you have a brute force compute, right? So that means you are paying for the compute in the cloud. So instead, you only process what has changed rather than processing all of that. And then you have fine-grained granularity, like who has access to what data, what field, what tables, and all of that. And you can also monitor the quality, like how many records were bad, who has made the change, what are the failed records. Again, as you're automating, you have the entire life cycle of the data. And you can look at the data quality, like how many have passed and things like that. So you have a mechanism to manage all of this data lifecycle. But then comes, if you have hundreds of vendors, you have several departments, if you have a large organization, how do you share data? That's where there's a new protocol called delta sharing. So the idea is you share data securely without data duplication. So here is an example where you have data from multiple clouds, like Azure, AWS, and you have data in different tables. And somebody like a business analyst is looking at using a Tableau interface, and you have data providers and data shares. So it's an open, secure access, and the data doesn't move, and you're able to access the information. So this is the new standard for data sharing across organizations, across vendors. So ultimately, it all boils down to why do we use Lakehouse, right? So it's all cloud storage. It can support different data types: streaming, non-streaming, unstructured data, structured data, time series data, change data capture, data governance, which is a big piece for all of this. So you can go back to the previous version. You can look at you can completely do an audit trail, and it's highly scalable. Some of these Lakehouse, they're, for example, HSBC Bank is processing several petabytes of data using the Lakehouse architecture. NASDAQ is using the Lakehouse architecture. So, and then it's all pay per use, right? So you can, again, depending on the need, you can even a small shop can start with Lakehouse versus a big, large company, right? So we are actually implementing it, and we are seeing 50% cost reduction, both in people, time, in data migration, and data governance. So you can really achieve the cost savings with this implementation. And then you can build contextual data analysis, right? Here you're looking at all the wells, the subsurface elements. Here you're looking at the geomechanical model and also the production. So since the data is all in one place, all streamlined, cleansed, and all of that, so now you can build contextual data analysis. So with all of these, we have built solutions, one for the mature field. So if you're looking at mature field, like with all the cost sensitivity, now the drilling activity has picked up, but previously there was very little drilling activity. So they wanted to improve production, right? So we provide optimal completion design. So the idea is to identify which zones and wells require reperforation and increase production. We provide 3 best completion designs to maximize production, and also efficient workflow for well construction. That's with the GeoFlow software. And then we have a completions database. And then here is where we have the modeling. In this case, we do the reservoir flow model. And ultimately, we say which zones are producing, what you get at the sand phase, what you get at the surface. So you're trying to optimize production. This is pretty much for the mature field. And also the GeoGlass software basically does a continuous monitoring with fiber optics, like if you're looking for real-time wellbore events. So essentially looking for zonal flow estimation using the distributed temperature data, and looking for any kind of event detection. So this is pretty much for the mature field. For the green fields, we want to mitigate drilling risks, right? So here is where we have the seismic data analysis with GeoCrust, where we are looking at 3D rock properties and how you change over time, and also the property variation, and also identify what is your best path that has least resistance and least stresses, in order to least horizontal stress. That way it doesn't lead to any wellbore collapse. And that is where we do the geosmart geomechanical analysis, where we take from 1D rock properties to 3D rock properties, and basically mitigate any wellbore stability problems and potential well failures. So this is for the green field, and also any kind of new wells that you're drilling. And there is also a real-time geomechanics component for that. So in all of this, I mean, we have looked at, as I said, like from a 10,000 foot view to how do you actually get started, right? So you want to engage business and identify problems to solve. That's exactly what Phil was saying earlier. Whether you want to increase your process efficiency, you want to do data cleansing, you want to do governance, you want to do vendor management, or you are looking at a real-time, faster delivery, real-time management of all the data. And do you want to do contextual analysis, or you want to do exploratory versus predictive? So we recommend, identify one field, have a POC or a pilot for the data sets, and have measurable KPIs, typically in 4 sprints, and basically iterate on the deliverables, and basically use pay as you go. So that's pretty much what I have. So I wanted to go take from, how do you actually get started with all of these, Thank you.
Thank you. That was really practical and wonderful. So, so I have a couple of questions. So the first one that came in, I see Susan Foreman's question, but I also have a question that came in personal, or to direct question, came in first. Is for Philippe. So Philippe, there were a couple of places where you did remote inspections. And like, for example, at the convenience store and the gas station, where you were able to identify whether or not they were in compliance, they had their fire extinguishers. How did you get the images?
So today we have billions of video cameras around the world, which are typically recorded. The data is getting recorded somewhere. Sometimes those data feeds come to a control center, typically airports, cities, where you get thousands of cameras. And there is one guy trying to watch at all the camera and he sees maybe 10, 20, 100 cameras at a time. So those data feeds exist and are occurring. What we are doing now with Visual AI is we capture those video feeds which are already coming in, and we 24/7 we analyze those video feeds with. Today we have about 120 models that we can choose from, depending on whether we are looking at, is this a perimeter security challenge? Is this an HSE challenge? Do we want to know if people are wearing their HSE? If this, do we have people walking below overhanging loads? And what we do is, all of this is happening real time. If there is an immediate recognized risk, we may warn a person, we may flash some light, so we may stop a machine. I mean, in the manufacturing environment, we have a use case where we actually stop a machine if somebody we recognize is coming too close to it. So those use cases are all very different, but generally speaking, it's the same thing that we see with a lot of the use cases that we work on. The data is already there. It's available. It's just not used, maybe not managed properly, because there was, we don't know what to do with it. It's just there. But once you start to say, well, we could use this data to do something, then organizing it becomes very simple, very straightforward, because now you have a business objective. This is what we need to do for that particular reason. From there on, organizing the data for a business need is simple, and really to get access to the various video feeds around the world is very straightforward. I mean, there's not much complexity into that.
Oh, that's interesting. And so basically you just select among the available sources, whether it be satellite or somebody's security network or drone survey.
I mean, the biggest market is really with all the existing video cameras that are available at the plants in cities, in refineries, in vast industrial plants. There are billions of cameras on the world already streaming, and very often they stream, and at the end of the day, it gets recorded somewhere, and most of that footage is not looked at unless something happens, and you go back to look at what happened at that particular point of time. But most of the information is recorded, is just recorded and stored somewhere. So what we do, we look at the data in real time, and we have dashboards to look at, how many type of events are happening. If you look at safety, how many times are people not wearing their hard hat or their safety jacket or the wrong glove for a particular job? Or do we, one of the biggest problems with gas station is the fire extinguisher gets stolen. Is the fire extinguisher still there? And so we do a bunch of statistics, and then you can manage your company with statistics. What is the biggest risk we have today? Well, the biggest risk is that people are wearing the wrong gloves to do welding or chemical work, or they are not getting, putting their hook when they're on scaffolding. So once you know what is the biggest risk by number of events, you can really manage it and mitigate it. And if some of the risks we recognize are too important, then we actually raise an alarm.
Oh, that's perfect. Well, thank you. It's very, very useful. So we have two questions. Susan Foreman asks, with 1.5 million acres of mineral estate, currently approximately 12,000 producing wells and 120 years of producing from 350 combinations of formations, we are currently trying to build a system to capture data from multiple sources. This sounds like the Osage Nation, I believe, and have a need to keep updated. We are struggling with different sets of identifiers from different sources. Could Mr. McDowell speak to this problem again?
Yeah, sorry, had to unmute my mic. I think so. Susan, for us, let me go back to my PowerPoint real quick. What we've actually boiled this entire thing down to a 4-part system, which is this data source, data collection, and data type. And honestly, between each one of these, it actually works pretty well. We use this for everything. So data source. So for this example, it's Midland Library. That's the 023. We also do this for, say, if it's a publication from AAPG, if we use that internally, I forget, we have a number code just for AAPG as well. Now, remember, for that, you have 999 unique data sources before you even start to use letters, much less letters and numbers together. And then the other one, too, is the data type. This is the one that we lean on pretty hard. So I think at the end of the day, we work with a lot of physical data, a lot. I mean, we literally have almost 2 million pieces of paper in our library, not to mention the well files that we're constantly getting on from operators. So what, from my perspective, is start with the easiest stuff first, stuff that's essentially found on one piece of paper, right? So indexing like a report that's that has hundreds of pages, or say it's a binder of hundreds of reports, right? For those, it doesn't make sense to go through and put a sticker and take an image of it, right? You might as well just scan the whole thing from the get-go, right? And then you can always run the OCR and text recognition, all this stuff later on. That system is really simple, but it's worked really, really well for us. And we have, if you go out to our geologic data directory, it's sabata.us/directory. You can see we have just shy of 10 million records, data records. So this is stuff from close to 60 different data sources, and it's totally seamless of whether it's a piece of paper that has an image associated with it or not, or whether it's an LAS file. You really see no difference whatsoever in there. Once you kind of get that coding system, it works really well, to be honest. It's a very simple system, but that only gets it to where you can index everything, which to me is the hardest part. Once you index everything, then going through and scanning and running all the OCR and all that other stuff, is it a lot of work? Absolutely. But there's a ton of commercial solutions for that. Actually indexing data and cataloging what's there. There are very few commercial solutions for physical stuff. So hopefully that answered your question.
That's great. Well, there's some great chat going on, and we're going to stay here as long as we have. I've booked this for another 30 minutes. So if people want to stay on and keep on talking, that's really great. And so we'll keep going through the questions. So we have a question for Sashi. Do you have these automated geomechanics models just to input data and obtain results? Let's see, who was it who answered that? You might turn on your microphone and elaborate a little bit.
Yeah, I can hear you. Yeah, go ahead, Susan. Yeah.
Oh, no, but I was thinking for, let's see, who asked the question? It was Lydia Kano. Lydia, you might want to elaborate the question a bit.
Yes, it was me. So he was showing some geomechanics models, and well, he said that the information, the models were there, and then it can be, those models can ingest data, and then that data can be doing a 1D model and a 3D model to generate output. Maybe I misunderstand that, but I thought that was what the workflow that he was presenting was. Can you elaborate a little bit on that?
So
Yeah.
automating geomechanics models, yeah.
Yeah. So first I'll address the area of missing data. Like for example, if you want to compute vertical stress, the data usually starts from much below than the seabed. So in that case, we do an interpolation or we do a machine learning based curve to fill the data because you want to compute the stress is cumulative, right? So that is how we address any of the missing data because you want continuous information. So that because the bottom depths have an impact on that. So that is how we address the missing data. The second thing is if you look at a geomechanical model, most of the data is above the subsurface, above the reservoir. You have the seismic, you have well logs, all of that. But if you're building a 3D geomechanical model, you want to know what is your side burden, what is your under burden that is below the reservoir also. And you want to see how it changes over time. So that's where we use the meshing in order to first build the geomechanical model, apply the constitutive model, and then fill in the properties, and then use those rock properties for collapse pressure and other further calculations. So pretty much you want, in order to have effective collapse pressure, you want the vertical stresses and the horizontal stresses, the minimum and maximum, and also the formation pressure. And then using that, you would now, and also all the different rock properties, right? So we for the 1D model, it's the same. For the 3D model, you want to take the boundary conditions as well as the side burden, overburden in order to build the full 3D geomechanical model. So that would be used actually for sidetrack, especially with real-time geomechanics. When you have a failure, then using the 3D geomechanical model, we can now estimate the properties and then qualify what is your path for your sidetrack. So.
Nice. Okay, so we have another question from Vinicius Botelho. Great presentations, everyone. Thank you for the content. I'm a data scientist from Petrabytes, and currently we are interested in building a database of our cleaned data used for machine learning projects so as to save time for future projects. I believe it was the gold database that Sashi talked about, but do you have any use case or example of that being done without needing to duplicate the information? Because we have a big centralized database. How would you do that more specifically? That sounds like a day's worth of answers. Anybody want to tackle it in a second?
I will take a sequential approach to address the problem. What Brian is solving is actually a very dirty problem. It's very tough to solve that problem, to take the old data sets and actually make sense out of it, right? So OCRs and all of that, it's very difficult to do that, to do it properly, right? Many people claim that they can do that. So that is the first step. Then comes the scalable problem, like it's not just the well logs, you have other subsurface elements, petrel formats like GRDCL, all those other formats, right? So that's where this Delta Lake, which can take data from multiple formats and aggregate together. So typically, if you have existing databases, you actually map those into the bronze layer. So the bronze layer is what they call it's a data aggregation layer. And the silver is where you cleanse the data. For example, missing logs, null values, interpolation. So that's how you create the cleansed data set. In all of these, you're not duplicating it, you're only enhancing the data. And when you look at the gold data standard is where you can dynamically build queries. So one of the main advantages with this elastic, like the Delta Lake, is you can do queries on the fly for large scale queries. Like for example, you can say, give me gamma log for all the zones that have these problematic zones, like the problematic areas, like tight spots, right? So that is how you can correlate with all these relationships and get the data out of it. You don't have to join all these tables on the fly. You can do in-memory processing in order to get the data. So you minimize the data duplication and use the in-memory Spark to actually query and get the results.
Okay, great. So does anybody else want to tackle? Okay, so here's another question. But anybody else have any thoughts about Vinicius's topic about?
I mean, Vinicius, yeah, handling data from, and thank you for your question, handling data from many different databases. What you want to consider, I would think, is knowledge graph representation, where you go and understand what is in each database and be able to build from that without having to duplicate everything into a new one. So love to speak more with you about you if that's of interest. But generally speaking, knowledge graph and natural language processing provide a lot of way to approach this type of challenges.
Nice. So I think Sashi might have already addressed this more or less, but question for Sashi, how do you approach a machine learning problem in which you have lots of data, but the critical data is generally missing? Do you ignore everything that is not a complete data set, or do you try to interpolate to fill in missing data?
In most cases, you do the interpolation, but you also want to make sense out of it. So in all of these, I think most of the times we do the interpolation from the derived data sets, from the already offset data sets. That is how we approach the problem. So.
Anybody else? How about you?
Typically, you can do also the principal component analysis, where you can say, because ultimately you have 50 variables, you can reduce it to the 10 most critical variables, and you want to validate if the data that you think is critical is really critical in the overall scheme of things, right? So you can reduce the dimensionality as well. So.
And also, well, Brian, what are your thoughts about that? What do you do when there's missing data?
Move on. I mean, in all honesty, what we're doing, we're never going to finish. We'll literally never finish what we're trying to do, right? Where we're just trying to index everything that's available, right? I mean, and I think it's a fool's errand to think that you ever will achieve that. To be honest, is that get what you need to get the job done and just move on to the next project, to be honest. Because at the end of the day, just adding more data doesn't mean that your models are going to be more accurate necessarily, right? More often than not, as you get to higher and higher data counts, then you have to deal with more normalization, standardization, so on and so forth. And, rather than actually getting oil and gas out of the ground, right? You can spend all your time tinkering on stuff. Rather, I mean, there's obviously, it depends on the size of the project and the focus of the company and all this other stuff. But, for us, going out from being a bigger operator to being independent now is like, I know a lot of people that done very, very well by just getting a handful of logs doing closology, and I think that's where that's where people really need to focus on, is like, just, you don't need to have everything all the time, right? And I think a lot of us are used to that. So that's just my 2 cents.
That's an interesting point, because a lot of effort, and Philippe may be able to talk about this, a lot of effort has gone into sort of creating, especially in geophysics, kind of like 5D or sort of an idealized perfect prototype based on predictive qualities. And so the idea is that you could probably recreate and any kind of missing data set. But anyway, you can recreate the missing elements with some kind of certainty.
One of my favorite quotes that my buddy always says is that maps are never finished. They're merely abandoned, right? It doesn't matter. You can be working on those for decades, right? At some point you just got to make a decision and move on with your life. I mean, I love tinkering around the data stuff. Don't get me wrong, but it's time versus effort. And at some point there's always going to be diminishing returns, right? You just have to figure out where that level of diminishing returns, is it in your organization? Is it a P70 or is it the P99? Right? If it's $100,000 project, that's a much different thing than $1 billion project. Right. So I think, keeping it's hard to just kind of sum it up in the rules of thumb, right? I mean, you've got to keep the context in there, at the end of the day.
Yeah, that's true. So Philippe, how do you deal with missing or even the issue of sparse data?
So, if you look at the technology we have tried to build is very much for the industrial world. I mean, in the commercial world, AI is very present, but there is an abundance of pictures of cats and dogs. And so there is a lot of data points on that availability of data. When we move to the industrial world, we don't let our refineries and we don't let our drilling rig explode or on a regular basis. So we definitely have a lack of data about what problem looks like or what, and then in the data itself that we're getting, there is a lot of missing data. So how do you deal with this data? So we have patented a lot of technology to look at this, but if you interpolate for missing points, that means you already know the solution. So what are you going to interpolate on? Why do you want to interpolate? So each case has its own challenge, and you need to look at what is the challenge you are trying to solve, what is the business value, and what is the acceptable margin of error on the risk you want to take by interpolating. And sometimes it's just interpolating makes no business sense. It may make a data science sense, but if there is no, if on the business side it's not logical or it doesn't bring the value you're looking for, then you're not going to achieve what you want. So how do you define the technology to use for every problem? I stress that you always want to go back to the business challenge. Unless you know what is the importance of what you're trying to solve, you are going to make the wrong data science decision. And so it's very important that your data science team is in very close contact with the subject matter expert on the business users, so that you develop solution which makes business sense.
Yeah,
Really nice point.
Yeah, just one quick example, like for example, when we are doing the real-time geomechanics, the time is of essence, so you don't have data. So in this case, what we do is we have three models. One is the most likely best case and worst case for the collapse pressure. And that is how all of these are based on 3 different plans, some interpolated, some are forecasted models. So based on that, we have 3 models that help you, monitor the well to mitigate the risk within the 3 boundaries, like best case and the worst case. Because in this case, you have to complete the well within 14 to 15 days, right, during the drilling time. So.
Yeah, really, those are really good points.
Maybe as we wait here, I'd like to stress something. The use cases I've presented are the ones I'm allowed by our client to speak about. But we actually do a lot of work in the world of seismic. A lot of works are in seismic. Unfortunately, I cannot speak about those projects. But when you use artificial intelligence, if you have data, lots of data, and in fact, the more data, the better. AI is actually coming into the resource. The challenge that was in that question is what you do on the other end, where you got sparse and missing data, and that is a challenge. Absolutely. I mean, sparse data and missing data is you need to think about what is the physical world you live in, and what would be the best solution for that particular challenge. Does it make sense in the physical world?
Exactly. And I think that one of the things that you pointed out, and also Sashi, is that we really are looking at bias here, and cognitive bias, confirmation bias, but we tend to come to a data set with what we think we want to have as the outcome already in our minds, and that shapes, we might call it framing, but we have to be, like you both pointed out, you have to be really careful that you don't just turn the cat into a dog.
Absolutely. I mean, bias is a complicated thing. We have demonstrated it with tons of data in the commercial world, and that's something you want to be even more careful in the industrial world, because what you want is the cost of being wrong is a lot larger in the industrial world than it can be in the commercial world. So somebody may get his feeling hurt if you identify him as a cat, but if you kill him, it's a lot worse.
Most definitely. I really appreciate all of the questions and the interaction and the great presentations. And again, just to remind you all, you'll be getting an email with some materials. You'll get a link to Zrathis collaboration platform. And I'm going to ask each of the presenters to provide a PowerPoint too. It's been requested. We'll put that in Zrathis where people can retrieve them. And we'll also put a few other things. And we'll think about a collaboration challenge for the platform so we can have an ongoing hands-on. And you'll also get a copy of the recording. And I want to encourage you to share the copy or the link. So I wanted to make sure that as many people as possible are able to benefit from these wonderful insights. So thank you very much, everyone. And want to just thank you again for the fantastic presentation and set of discussions. And we'll be in touch.
Thank you all.